Capacitance is defined as the capacity to store electrons in form of electric field while opposing voltage changes. Also, capacitance is directly associated to the material permittivity, where it could be low or high, and according to the material formation. The device that stores electrons is called a capacitor. To build a common capacitor, two parallel metal conductors separated by a dielectric material and insulating material must be used. It should be noted that different shapes can be used too. Also, one plate cannot be used as it will cause the circuit to be shorted. According to the previous mentioned fact, every element in this universe is neutral by nature, since its positive and negative charges are equal in numbers. However, when an external voltage is applied to the capacitor plates, the transmitted electrons begin to repel the existing electron found on the first and second plates, according to Coulombs Law. The first plate begins to absorb the transmitted electrons and distribute them evenly throughout its surface, and pushing the electrons located on the second plate toward it. In this place, the majority of electrons are collected in the first plate, surpassing the original amount of metal protons and therefore becoming negatively charged. Due to the initial amount of metal electrons being pushed toward the first plate, the second plate will only have its original number of protons, leading the plate to be positively charged. When the first plate is saturated, no more electrons can pass across it, and so the charges are stored. That charge storage creates a potential difference between the two plates, which can be utilized when the primary voltage source is run off. Direct current does not pass through the capacitor because of the dielectric, as it flows in a linear direction. However, alternating current can flow through the capacitor, bypassing the dielectric, as it flows in a sinusoidal manner. The role of the dielectric found between the capacitor plates is to polarize them, enhancing the separation of the positive and negative charges from each other when external voltage is applied. Ceramic is an example of dielectrics. There's some factors that influence the capacitance strength, such as, first, dielectric material permittivity. As larger the permittivity, as larger the capacitance. Second, geometrical formation. As smaller the distance between capacitors' conductors, as larger the capacitance. As larger the sectional area of the capacitor's conductors, as larger the capacitance, and that means more charges to be stored. The geometry of the capacitor, which its capacitance differs from shape to another. Materials capacitance is measured in farad, while materials permittivity is measured in farad per meter. That was the third element that has an effect on the electric circuit. The fourth and final element shall be introduced in the next episode. But that is left to the next episode, so ensure that you're subscribed and click the bell icon. Please help us by liking, commenting, and sharing. This encourages us to deliver more. Wait for the next video on the Electricity and Magnetism channel, and we'll see you next week.